Hello friends, today we will discussing about the enzyme kinetics. In the lecture 1 already we completed, that is enzyme definition, properties and classifications of the enzyme. According to the PCI syllabus, the next topic, that is enzyme kinetics. It is the second lecture of this enzyme unit. Here in this enzyme kinetics, the main important point is the definition and the factors affecting the rate of the reaction and the Michaelis-Mentos equation and Lineweaver-Burk equations. Let us to see the one by one, that is enzyme kinetics. The meaning of enzyme kinetics is the study of chemical reactions that are catalyzed by the enzyme, called as enzyme kinetics. Here the enzyme kinetics means एंजाइम जब किसी रिएक्शन को कैटलाइज करता है और एंजाइम किस रेट से और किस स्पीड से कैटलाइज करता है उसके बारे में स्टडी करना ही एंजाइम काइनेटिक्स का बोलते हैं. इट इज कॉल्ड एज द एंजाइम काइनेटिक्स. एंड द टारगेट मॉलिक्यूल्स मीन्स the substrate binding. Here friends, the substrate or the reactant binds to the enzyme at an active site and transferred into a product through a series of steps known as the enzymatic mechanism. Here let us to take one chemical reaction. Here substrate plus enzyme rate or concentration rate to give a product. Here the substrate, the target molecule means substrate or reactant, the bind to the enzyme at active sites. Here these reactant or substrate is bind to the active sites of the enzyme. That the enzyme having a active or allosteric site, it binds to the active sites and it transfers into a product. It is known as the enzymatic mechanism. Here always when in the general reaction enzyme is present, the substrate or reactant is converted to product is more faster when compared to the absence of enzyme. It is the definition of the enzyme. We know already, we seen in the previous lecture. And the second one, that is here first we must to know the basic parameters of this enzyme kinetics. Here comes the basic parameters of this enzyme kinetics, that is zero order of reaction, first order of reaction, second order of reaction. The meaning of the first order of reaction, the basic parameters of this topic, that is enzyme kinetics. The zero order of reaction, first order of reaction, that is second order of reaction. The first zero order of reaction, it does not depend on substrate. Here the zero order reaction, it said that it does not dependent on the substrate. Here it doesn't dependent on the substrate, either its substrate or increases or decreases the rate. Here it does not dependent on the substrate, that is known as the zero order of reaction. The first order of reaction is fully reciprocal to the or reverse to the this zero order of reaction, that is depend on substrate. Here it is depend on substrate, that is when the substrate rate increase or decrease. When the substrate rate is increases, the rate of the reaction, that is the reactant is converted to product, will get more faster, and the substrate will decreases. Its effect on the first order of reaction, it is fully dependent on the substrate. And the second order of reaction is, it is depend on both, that is substrate as well as the rate of reaction and enzyme rate, the rate of reaction. Here its second order of reaction said it fully dependent on the dependent substrate and the enzyme, the concentration. When the enzyme concentration is increases, the substrate is increases, the enzyme concentration also be increases, and the product will get a faster. These are the order of the reaction comes under in a enzyme kinetics. But in this enzyme kinetics only we studied zero order and first order of the reaction, because of due to the enzyme is fluctuates and it's constant in our body. Due to the only we studied first order and the zero order and first order of the reaction. The rate of the factors affecting a rate of the reaction. Yeah, the two factors, that is the collision or kinetic theory, and another one is the activation theory. Yeah, the collision theory, it said that the collision theory state that the two molecules, here it is a one molecule and it is two molecules, it approaches with a bond. Here these molecule is approaches with a bond, the forming a distance of one another. Here it one molecule and two molecule, it form a bond with a another with a approaches with a different distance. So the molecules need to sufficient to kinetic energy to remove the barrier towards the each other and form the product by reaching a transition state. It said that these two molecules, it's break, it's have a one, it's have a it capable to have a energy to break its bound and to form a new bond with the another molecule, that is that is called as the collision theory. Let us we see the with example. The example, that is, so A, B plus C is gives A to bound, make a bond with B and C to form A, C plus B. Here A and B are the two molecules and C are the another molecules. This they are the one molecule, and already these A and B make a bond between A and B, and this collision theory state that it's A and B have a capable to one property that it's break its bond. These molecules have a capable to break the bond between these two molecules, that is A and B, and these molecules to break and to form the new molecule, to form a new bond, make a bond with a C, that is A and C. It is called as a collision theory. इसका मतलब ये है कि ए बी सी तीन एक मॉलिक्यूल है और ए एंड बी ऐसा प्रॉपर्टी रहना कि और इसके पास ऐसा एनर्जी रहना कि ए बाउंड उसका बाउंड ब्रेक करना और ए ब्रेक करे सो बाउंड जाके ए मॉलिक्यूल जाके अनदर न्यू बॉन्ड के साथ ज्वाइन होना, इसको ही बोलते कोलिजन थ्योरी. एंड इट इज अ ट्रांजिशन स्टेट. It is a transition state. This a transition state means old bound break and new bond form. That is simply it is called as the collision theory. And second one, that is activation energy. The activation energy means here the activation energy, the energy to activate or remove the energy barrier between the substrate to reach the transition state to known as the activation energy. This activation energy, for understanding this activation energy, to take a one general graph. Here एक पहाड़ है और इधर एक पत्थर है. इस पत्थर को इधर से इधर तक लेके आना ही उसको ही बोलते हैं हम एक्टिवेशन एनर्जी. और इधर एनर्जी अप्लाई करते हैं। इधर से इधर तक कितना फोर्स लगा के कितना एनर्जी रिक्वायर्ड करता है ना, उसको ही बोलते हैं हम एक्टिवेशन एनर्जी। Let us and y-axis, and here energy, and here the progress of the reaction. Here to plot graph like this is a product, this is a reactant, don't get confused. A plus B, this is a reactant. C plus D, this is a product. Here it is a activation energy. When the activation energy is always required a two short way, that is a reactant is converted to product. Here in this activation energy the enzyme is present. When the enzyme is present, the reaction is too faster, that is called as the activation energy. Here we take one example, that is example. Here the examples of this activation energy. When the hydrogen peroxide is converted to water and oxygen in the when we apply a 86 kg per mole energy, then only this hydrogen peroxide is break into this water and the oxygen. At that time, this hydrogen peroxide, it required the energy is required to appropriate the enzyme catalyst as present. When the enzyme catalyst is present, it's required only 1 kg per mole of energy to break the hydrogen peroxide to the water and oxygen. Here the hydrogen peroxide is break with the help of the one organelle is present in our body, we call as a peroxisome. It's convert the hydrogen peroxide into water and oxygen, and this peroxisome is protect our body from the hydrogen peroxide. This is the factors affecting the rate of reaction of enzyme kinetics. In this enzyme kinetics, two equations are comes under, that is Michaelis-Mentos Equations and second one Lineweaver-Burk plot. These are the two graphs of comes under in the enzyme kinetics. Let us to study the Michaelis-Mentos Equations. The Michaelis-Mentos Equation, that it is a equation is give the mathematical relationship between the substrate, that is substrate concentration and initial velocity, that is we written as a vi. It is the initial velocity. These are the relation between the relations between the initial velocity reaction and the substrate concentration as shown in the graphically. And here the equation, the Michaelis-Mentos equation, that is v initial velocity, that is v maximum into substrate concentration and Km plus substrate concentration. Here the Km is Michaelis-Menten equation, that is constant. And V maximum is maximum velocity, Vi is initial velocity, and the concentration of S is substrate. Here if the substrate is constant, when the at the time of the substrate is constant, the velocity of the reaction is half of the maximum velocity. Therefore here the mainly the three conditions we can evaluate the Michaelis-Menten equations. That are three conditions. Three conditions can evaluate by this equation. First to see the graph, and next while we seen these three conditions, then you will understood the how the graph is comes. Now that is graph, that is x-axis, y-axis. Here this is velocity, here it is substrate concentration, it is initial velocity, and this initial velocity, it is v maximum, it is the half of the v maximum, that is it is v maximum by 2, it is the half of the v maximum. Here this is first order of the reaction, and this is the zero order of the reaction. Here it is a zero order, it is the first order of reaction. Always the zero order of reaction, it doesn't depend upon the substrate, and it means it's a constant. While we add a more substance, then only it's move on the at a constant constantly. When we add a more substance or a less substance, it dependent on the first order of the reaction. First order of the reaction, it says it's dependent on the substrate. This is the graph of this Michaelis-Menten equation. Let us to see these three conditions. First one, that is when the substrate is, this is the concentration of substrate is much less than Km. It is the first condition. Here we know the equations of the Michaelis-Mentos equation, that is V maximum into concentration of substrate and the Km plus the concentration of substrate. Here what is the condition when the substrate is much less than the Km value, means here the substrate is neglected, therefore the substrate is neglected, that means the substrate to become a zero. After here the substrate is zero, means V maximum into concentrate substrate and Km plus 0, that it give A into Km. Here it is V initial velocity. Here V initial velocity is directly proportional to the concentration of substrate. We taken as a directly proportionality. It is the first condition. V initial velocity is directly proportional to the substrate, means here when the initial velocity is increases, the substrate is also increases. It shows the first order of the reaction. The second condition, that is here the second condition, that is when the substrate is much greater than the Km, that is the first to write the equation, that is V max into the concentration of substrate divided by the Km in plus concentration of substrate. Here the greater than the Km, that is here the neglect to, here we neglected the Km, that means Km is 0, the equation is V max into, that is substrate and concentration of substrate and concentration of substrate, that is initial velocity. The concentration of substrate to get a cancel, that finally initial velocity equal to the V maximum, and it is the second condition. And to third condition, that is when the substrate is equal to the Km. When substrate is equal to Km, to write the first the Michaelis-Mentos equation, that is V maximum into substrate Km plus concentration of substrate. Here the condition is when the substrate is equal to the Km value, that means Km is equal to substrate. The meaning of this condition, that is Km is equal to substrate, there you can write the equation like the substrate plus substrate V max into the concentration of substrate. These are 1 plus 1, that is 2, that is 2 substrate. Here the V initial velocity, one substrate and another substrate to get a cancel, V max divided by 2. The initial velocity is the half of the maximum velocity, that is initial velocity is half of the maximum velocity. You can see by the graph, it is a graph. The first condition, that is V is directly proportional to the substrate, and third one, the initial velocity is equal to maximum velocity, and the initial velocity is half of the maximum velocity, that is initial velocity, that is maximum velocity half of this initial velocity, and it directly proportional to the relation is the relation is the initial velocity is directly proportional to the V maximum. It is the Michaelis-Mentos equations. And the second one, that is Lineweaver-Burk plot. When the V maximum is plotted against in a Michaelis-Mentos equation, it is difficult to fix the point of the V maximum. When V maximum का point फिट करने, दैट इज इट सेट करने के लिए डिफिकल्टी हो रहा है, कि इसलिए हम लाइनवेयर-बर्क प्लॉट ड्रा करते हैं. इट डिफिकल्टी टू ओवरकम बाय द रेसिप्रोकल ऑफ द velocity, initial velocity and the concentrations of the substrate, then it plot. The result curve is linear. When we plot a graph of this Lineweaver-Burk plot, the curve is linear, then that is called as a Lineweaver-Burk plot. Then the Km and the V maximum can easily obtain from the plot. Here to see the first of all, this Lineweaver-Burk plot is the reciprocal to the Michaelis-Mentos equation. First to write a Michaelis-Mentos equation, that is V maximum into substrate and Km plus substrate. Here it is reciprocal to the it is reciprocal to the Michaelis-Mentos equation, that means 1 divided by V initial, it's reciprocal Km plus substrate divided by the V maximum into S, and this reaction you can written like Km V max into substrate plus the substrate V max into the substrate. Here the substrate to substrate to get a cancel, the equation you can the written as the 1 by the initial Km maximum velocity substrate plus 1 by V max, and this is equation is for the straight line, that is this is equation is for the straight line, that is y equal to ax plus b. Here y is the 1 by initial velocity, a is Km V max maximum, x equal to that is 1 by substrate, and the B equal to 1 by V max. Here the X and A and Y and B. And so the 1 by Vi, that is the initial velocity, is plotted as the function of 1 by substrate. It's give a straight line to whole intercept, that is the intercept is 1 by V max, and the slope of this plot is Km divided by V max. And now in equation y equal to ax plus b, y equal to 0, then 0 equal to ax plus b, then a minus ax b, then x equal to minus b by a. Then you substitute this b and a value in this equation. After the substitution, the a and b, that is minus v max into v max divided by km. V max get cancelled. The x equal to the minus 1 km. X is the minus 1 km. The x-axis on the km, that is Michaelis-Menten, the reciprocal equation, that is minus 1 km. Let us to see the graph. The graph of this Lineweaver-Burk plot, that is, it is x and it is y-axis and it is x dash y dash. Here it is a intercept, the slope, that is km v max. It is intercept v max, intercept, and in the y-axis, that is 1 by v I, that is initial velocity, here 1 by the concentration of substrate, and the finally the x-axis, x equal to minus 1 divided by km. Here these, the minus 1, here k minus is on the x dash axis, that is on this point the minus 1, the km value is come. This is the Lineweaver-Burk plot graph. And if you want to notes, you can join the WhatsApp group. The WhatsApp group is available in the description box.